In this video, we're going to look at completing a square where a does not equal 1, which creates a new level of complication. It's not insurmountable. You guys can handle this, no big deal. Let's say you're given this equation to graph. It's clearly a quadratic because it has a squared in it, but it's in a pretty weird form. Not too helpful in this position. So we're going to put it in standard form by multiplying this out. And at least with that, we wind up knowing that our y-intercept is 2. And we know our a value is 3, so it's open up and it's kind of narrow. And I suppose we could do negative b over 2a, but we are completing the square as what we're learning here. So let's do that so we get our vertex. So normally, first thing I do is move the 2, get it out of the way, so that we can deal with this and complete its square. So let's move that 2 out of the way. I like doing that first. There's other ways to deal with that. That's the way I like to deal with it, though. Now that we have this, we can't just go to something squared because we can't get 3x squared out of some weird x thing. Square root of 3x, I guess we could, but that's very strange. So at this step, what I propose doing is factoring out the 3. So this is the big difference. When you have a equals 1, you don't have to factor out a 3. You don't have anything here to factor out. But when a doesn't equal 1, you tend to factor that out of just these 2 terms. So we go to this. 3 times x squared minus 4x. Now, I'm going to leave a space here because I need to complete the square with this piece now. Okay, we're going to complete the square with this piece. Now, in doing so, let's see what happens. We're going to wind up with something squared. So in order to get this, we're going to wind up with x. In order to get this as our middle term, we're going to wind up with minus 2. Remember that this is always half of this. And then what we wound up putting here, what we had put here to get this, needs to complete the square. So this is the completing the square part. I'm going to use a different color for this. This is plus 4. Now, that's because x minus 2 squared is equal to x squared minus 4x plus 4. It just so happens that this 4 and 4 are the same. It only happens when we have a 4 here because 2 plus 2 is 4 and 2 times 2 is 4. So that happens only in that particular number, but so be it. So the other thing that's happening here is we needed to balance this equation. When we added this 4, we needed to balance the equation on the other side. But we didn't add 4. We actually added 12, okay? Because we have a 3 times this statement out here. So we actually added 12. So I'm going to add 12 to the other side, okay, to balance our equation. So therefore, this side becomes y plus 10, okay? But here's our completing of the square, the 4 and the 12. That's not really 4. It's really 3 times 4. So that's why we have the 12. All right, and then, well, then we're really pretty close. I'm going to move the 10 back. Now, there's ways of dealing with leaving the 2 over here and leaving those values over here. I like to move them out of the way and then move them back. But that's kind of up to you. So that means that this thing has a vertex minus 10, minus 10, plus 10, plus 12. I'm just checking the math here. Okay, good. So this thing has a vertex of 2, negative 10 is the vertex. And this is the a value, so that means it's up and it's narrow. All right, when I'm talking about it, I mean, I'm talking about the parabola, right? So we know we have a y-intercept of 2. We know we have a vertex now. We know we have an a value that's up and narrow. So when we go to graph it, let's see, we have a value of 2. We have a value of 2, negative 10 down here, 2, negative 10. That means also we have a value here of 4, 2, because it's symmetric about the vertex. And that even gives us our narrowness. It's a terrible looking parabola. Sorry about that, but that's the basic idea. All right, next video we'll do some equations where we're using completing the square to solve.